10 days. The window is closing. In 10 days, at precisely the moment when 3I/Atlas reaches its closest approach to Jupiter, the largest planetary magnetosphere in the solar system will interact with an object whose internal properties remain fundamentally unknown. What happens in that interaction will answer questions that institutional science has carefully avoided stating in direct language. Whether an object traveling across billions of years of interstellar space carries technological systems. Whether the internal structure of this object is consistent with natural formation or engineered architecture. Whether the 4 independent measurement campaigns that documented density anomalies, deuterium concentration exceeding natural solar system formation parameters by factors of 10, and chemical signatures inconsistent with any known cometary composition actually indicate what the forensic record suggests. This is not speculation, this is physics. And the physics of magnetospheric interaction at Jupiter will either confirm or eliminate the most significant question facing planetary science in this decade. Most astronomical discussions of 3I/Atlas approach Jupiter as a curiosity. An interstellar object passing through the solar system on a hyperbolic trajectory, pulled by gravity into an altered course, then departing toward the infinite darkness between stars. This framing misses the fundamental significance of what Jupiter's magnetosphere actually is, and what interaction with such a magnetosphere reveals about an object's internal composition and structural integrity. Jupiter possesses the most powerful planetary magnetic field in the solar system. The field strength reaches 16 times Earth's magnetic field magnitude at Jupiter's visible cloud tops. Extending outward from the planet, that magnetic field creates what physicists designate as a magnetosphere, a region of space where magnetic forces dominate gravitational forces. The Jovian magnetosphere spans hundreds of millions of kilometers in certain directions, creating zones where charged particles accumulate in radiation belts that dwarf Earth's Van Allen radiation zone in intensity and extent. When an object passes through such a magnetosphere, the object's interaction with that magnetic field reveals properties that optical observation cannot measure. An object composed entirely of rock and ice, the standard model for cometary nuclei, would experience minimal interaction with the Jovian magnetic field. The ions in the coma surrounding the nucleus would become trapped, creating a detectable wake pattern. The magnetic field would deform slightly around the solid object, but the internal structure would remain essentially invisible to magnetic sensors. An object carrying dense internal structure, engineered materials exceeding the density of natural rock, would interact differently with the magnetosphere. The magnetic field would exert detectable force on metallic elements within the nucleus. The charged particles surrounding the object would respond to the internal structure's influence on the external magnetic field. Any technological systems operating within the object would generate electromagnetic signatures detectable by the array of magnetometers, plasma sensors, and particle detectors currently stationed in the Jovian system aboard the Juno spacecraft. Those sensors have been operating continuously since 2016, monitoring Jupiter's magnetosphere in unprecedented detail. When 3I/Atlas passes through that monitored space in 10 days, every instrument will record the interaction. The data will not be ambiguous. The data will not permit multiple interpretations. The data will reveal whether the object's interior matches natural formation models or deviates in ways requiring alternative explanation. The Juno spacecraft operates in orbit around Jupiter, following a highly elliptical path that brings it close to the planet's cloud tops, then carries it far outward into the magnetosphere. Juno's magnetometer instruments possess sensitivity sufficient to detect magnetic field distortions at distances exceeding
millions of kilometers. The plasma sensors aboard Juno measure ion density and particle energy. The energetic particle detector monitors radiation belt behavior. The ultraviolet imaging spectrograph observes magnetic field topology through the light emitted by magnetospheric ions. When 3I/ATLAS passes within Juno's field of observation, every instrument will simultaneously record the encounter. The convergence of sensor data will create what theoretical physicists recognize as a multidimensional forensic portrait of the object's interaction with magnetospheric forces. That portrait will reveal internal structure with precision that no telescopic observation can achieve. The question that institutional science has carefully avoided stating is whether anyone actually intends to publish that data on an accelerated timeline. Whether Juno will be redirected to achieve optimal observation geometry. Whether spacecraft teams have already executed maneuvers to position Juno for maximum data collection on March 23rd. No official announcement has been made regarding any Juno redirection. That absence of announcement itself carries forensic significance. The magnetospheric cascade phenomenon represents what plasma physicists recognize as a chain reaction of electromagnetic interactions. When an object passes through a planetary magnetosphere, the interaction generates secondary effects. Charged particles trapped in the magnetic field respond to the passage, creating fluctuations in magnetic field topology. Those fluctuations generate secondary wave phenomena that propagate outward at the speed of light. The cascade can extend to tremendous distances if the initial interaction possesses sufficient magnitude. A sufficiently dense object, carrying sufficient internal structure, would generate magnetospheric cascades that would be detectable not only by Juno, but by magnetometer arrays positioned throughout the solar system. NASA's Themis constellation of spacecraft orbiting Earth continuously monitors solar wind and magnetospheric interaction. The Solar Dynamics Observatory maintains instruments monitoring the interplanetary magnetic field. The Stereo spacecraft constellation, positioned ahead of and behind Earth in orbit around the Sun, would all register signals from a significant magnetospheric cascade event at Jupiter. The combination of data from all these independent sensor platforms would create an unprecedented high-resolution picture of the internal structure and composition of 3I/ATLAS as revealed through its interaction with Jupiter's magnetic field. What such a magnetospheric cascade would demonstrate, if it occurred at sufficient magnitude, would be the presence of internal structure far exceeding natural cometary composition. The mathematical relationship between object density and magnetospheric interaction strength is well established in plasma physics. An object of standard cometary density would generate barely detectable magnetic field disturbances. An object matching the density measurements derived from the mass estimates documented in the 4 independent March observation campaigns would generate magnetic field disturbances at least 50 times more intense. Those disturbances would be unambiguous. They would not permit interpretation as natural cometary behavior. They would demand explanation within alternative frameworks. The institutional silence regarding Juno's preparedness or intended response to the approaching 3I/ATLAS encounter may indicate that relevant decision makers have already examined what magnetospheric interaction data would be required to confirm the hypothesis that 3I/ATLAS represents engineered structure rather than natural formation. The prebiotic chemistry payload delivery hypothesis connects directly to magnetospheric interaction physics. If 3I/Atlas carries prebiotic chemistry sealed within an engineered interior, the mechanism for releasing that chemistry to specific planetary targets would involve controlled outgassing, timed to coincide with closest approach to target planets. Jupiter represents the first major gravitational well in the object's departure trajectory from the inner solar system. An object designed to seed planetary systems with prebiotic chemistry would execute controlled release at Jupiter, ensuring that methanol, organic molecules, and chemical precursors to biological systems would integrate into the Jovian atmosphere and radiation belt structure for eventual transport to the Galilean moons. The controlled release mechanism would need to function reliably after billions of years of interstellar transit. Such a mechanism would generate detectable outgassing signatures during the magnetospheric interaction. The plasma sensors aboard Juno would record the composition of particles released during closest approach. The ultraviolet spectrograph would detect the chemical signatures of released molecules reflecting sunlight. The combination of data would reveal whether the outgassing during Jupiter passage shows evidence of controlled release or natural cometary volatilization. The string theory framework that theoretical physicists invoke when considering Type II civilization propulsion architecture permits calculation of precisely timed planetary encounters across billions of years. The symphony of strings that underlies 11-dimensional spacetime can be manipulated by sufficiently advanced technological civilization to calculate where planetary bodies will exist billions of years hence. 3I/Atlas trajectory, when analyzed through advanced orbital mechanics models, demonstrates optimization consistent with calculated precision arrival at multiple stellar systems across timeframes spanning billions of years. The object's current approach to Jupiter could represent a calculated close approach designed specifically to exploit Jupiter's gravitational field for trajectory refinement. A Type II civilization would not leave such an encounter to chance. Every aspect of the encounter would be calculated. Every outgassing event would be timed.
Every interaction with planetary magnetospheres would generate data intended to be detected by sufficiently advanced observers. The 10 days remaining before closest approach represent the final window when such calculations could be verified through direct observation. The forensic significance of the magnetospheric cascade extends beyond mere confirmation of engineered structure. The pattern of the cascade, the frequency components of the magnetic field disturbances, the energy distribution across different plasma energies would encode information. Mathematical information can be encoded in magnetospheric wave patterns, just as information can be encoded in any physical phenomenon exhibiting complexity. If 3I/Atlas represents an object designed for communication with sufficiently advanced observers, a magnetospheric cascade event would provide opportunity to transmit messages encoded in electromagnetic phenomenon that would propagate throughout the solar system. Every magnetometer would receive the signal. Every plasma sensor would record the data. The message would be distributed to observers incapable of ignoring it because the signal would appear in every sensor platform simultaneously. The institutional responsibility to examine whether such encoded information exists in magnetospheric cascade data represents exactly the kind of research framework that would require accelerated publication timelines, dedicated computational resources, and coordination between institutional rivals that normally compete for priority. The question that the 10 days of remaining observation window forces into the open is not whether 3I/Atlas represents an interstellar object. The question is what the institutional science frameworks already understand about what the magnetospheric cascade will reveal, and whether that revelation will alter how human civilization understands its position
within a cosmos populated by beings capable of achieving Type 2 civilization status. The data collection is automatic. The spacecraft observing is already positioned. The physics of magnetospheric interaction is deterministic. The calculation of what the interaction will reveal is already completed within classified research environments where institutional frameworks are permitted to examine questions without public transparency constraints. The 10 days represent the final opportunity for public science to prepare frameworks for integrating whatever the magnetospheric interaction data actually demonstrate.
After March 23rd, after Jupiter's gravity has redirected 3I/Atlas toward the infinite darkness, after the object has passed beyond the reach of any spacecraft humanity has launched, the moment of direct observation will have closed forever. The data will exist, but the opportunity to measure it directly will be gone. What occurs in those 10 days will determine whether the magnetospheric cascade reveals properties confirming the engineering hypothesis, or whether it demonstrates behavior consistent exclusively with natural formation processes. The answer lies in the physics. The question is whether institutions are prepared to examine what the physics actually show. The deep question underlying this entire forensic analysis returns to what the March measurements actually documented and what institutional reluctance to publish complete data actually signifies. 4 independent measurement campaigns converging on density values exceeding natural cometary composition. Deuterium concentrations 10 times above solar system formation baseline. Methanol ratios exceeding natural cometary baselines by order of magnitude. Preservation crust geometry consistent with engineered radiation shielding. Trajectory architecture optimized according to gravitational assist principles. Orbital eccentricity so extreme that the object's path appears nearly straight despite passage through the entire gravitational field of the Sun. Each data point individually could permit natural explanation. The compound probability that all data points belong to the same object through coincidence rather than design represents a number that institutional probability frameworks currently struggle to accommodate. Yet this is precisely the question that magnetospheric cascade data will answer with definitiveness. The internal structure revealed through magnetic interaction will either confirm the engineering hypothesis or eliminate it through demonstration of natural composition. 10 days remain. The physics will decide. The institutional landscape surrounding this moment carries its own forensic significance. Space agencies monitor 3I/Atlas with every instrument at their disposal. The scientific community has mobilized research teams to analyze every available data set. The aerospace industry has begun designing spacecraft modeled on 3I/Atlas's trajectory architecture. The policy research community has initiated frameworks for considering implications of confirmed extraterrestrial contact. All of this institutional response occurs without any official confirmation that 3I/Atlas represents anything other than an unusual but ultimately natural interstellar visitor. This pattern of institutional behavior is consistent with frameworks that already understand what the magnetospheric cascade will reveal and are preparing response protocols in advance of public acknowledgement. The 10 days represent the final moment when institutional plausible deniability remains viable. After magnetospheric cascade data is collected and analyzed, after patterns are documented and verified, after the forensic portrait of internal structure is complete, the moment for preemptive institutional positioning will have passed.
What occurs in those 10 days will determine whether the revelation of Type II civilization technology in the solar system occurs through gradual institutional acknowledgement or through sudden confrontation with undeniable empirical reality. The physics operates according to deterministic laws. The magnetosphere will interact with the object regardless of institutional preparation or institutional reluctance. The data will be collected. The analysis will proceed. The evidence will exist. And on March 24, 2026, when 3I/Atlas passes beyond Jupiter into the deep solar system, the object will carry with it a magnetospheric cascade signature that will have answered the question that science has been dancing around for months: whether an engineered artifact has visited the solar system, whether a Type II civilization has sent a message, whether humanity exists in a cosmos more populated with intelligence than institutional frameworks have admitted. The 10 days remaining will determine whether those answers reach public consciousness through transparency and scientific accountability, or through institutional silence that persists until evidence becomes too profound to deny.